Okay, this is substitution when we're solving systems of equation. As always, you want to be sure and know the objective that we have. It is 8.8, dyslexic moment, sorry, I had that backwards. The student formulates systems of linear equations from problem situation, use a variety of methods to solve them, and analyzes the solutions in terms of the situation. You want to be able to check off each of these statements when we are completed with this unit. So you want to be able to say that I can analyze situations and formulate systems of linear equations into unknowns to solve problems. That's more like day one when we were determining the equations based off of word problems. B says I can solve systems of linear equations using concrete models, graphs, tables, and algebraic methods. So far we've already learned how to solve systems of linear equations with graphs and tables, and today what we're continuing our learning on is another method that we can use algebraically called the substitution method. So we are on example 2. You have your steps. You have them either in the notes that were given to you, notes that you took previously, and or they will be going through each time we go through one of these problems. So we have 3y plus x equals 7, 4x minus 2y equals 0. Our first step that we've talked about is solving an equation for one variable. At this time, we do not have an equation that is already with one variable by itself. With that said, we do have an equation that it would be easy for us to use our mathematician magic and solve for one variable. The one that would be easier is the one that has x by itself. So 3y plus x equals 7 is going to be the easiest one to solve. And at this time, we're still in charge, so we can choose which variable we want to solve for. I hope you're getting familiar with determining what you want to solve for, and we're going to go ahead and proceed by solving for x. We're going to minus 3y from both sides. If you'll notice, we have on our right hand side, we have 7 minus 3y. Those are lined up, and one of the things that we want to talk about that we have been stressing is that we cannot combine those like terms. Even though we like to write it like this, we can eliminate our 3y on the right hand side, but the 7 and the negative 3y cannot go together because they are not like terms. So we just rewrite it as x equals negative 3y plus 7. And we have officially completed our step 1, our first process for substitution. And step 2 is to substitute. We solved for x. We know that x equals negative 3y plus 7. So just as we've been doing for a couple of weeks, we're going to plug that value in to the equation. So we have 4x minus 2y equals 0. We're plugging it in for x and x only, meaning that we're not going to take away any coefficients that are in front of x. We're simply going to put parentheses and plug in what we need. So we now have 4, open parenthesis, negative 3y plus 7, close parenthesis, minus 2y equals 0. The next step is to solve this equation. So I missed a step here when we combined like terms. So we have to distribute throughout the parentheses. When we distribute, that is multiplying 4 times 3y, negative 3y, and multiplying 4 times 7. Just a refresher. I wanted to make sure I touched on that before you guys stress out and you're like, where did those numbers come from? Well, we distributed throughout the parentheses. Reminder, if you always, or if you are having a hard time, always feel free to pause for a minute and to reevaluate, gather your knowledge of math, and get on the same page as us. So now we have negative 12y plus 28 minus 2y equals 0. I'm hoping some bells are going off in your head and you're thinking what you need to do next. If you're completely stuck, well, let me give you a hint. We are going to combine like terms because now we do have terms that are similar. So we're going to combine negative 12 and negative 2. Same signs, add and keep. We're adding 12 and 2 and keeping the negative sign. That's what you guys have known for a long time. Our new equation says negative 14y plus 28 equals 0. We're going to just solve it out like we always have. Get everything away from y. So we'll have negative 14y equals negative 28. Using our intelligence, we can think this through. We can continue by undoing the order of operations, or we can say, hey, what is negative 14 times something that equals 28? I know that negative 14 times 2 equals 28, so y has to equal 2. We have the first half of our substitution system of equations solved. So we have to solve for x too, but yay for getting the first half done. What we have to do to find the x value is plug y back into the equation. You can choose which equation you want to use. We're sticking to the equation that we just solved from, so we're going to do 4x minus 2y equals 0, and we're going to plug 2 in for y, just plugging it in, plug it in, plug it in. 4x minus 2 times 2 equals 0, so we'll have 4x minus 4 equals 0. Solving by using our magic mathematician skills, we will get 4x equals 4. 4 times what equals 4? X equals 1. Was rather quick, guys. That was a rather quick example. So rewind, pause if you need it. Come see me or continue using other examples that you have in the practice problems to work through. But geez, how dare me, I forgot one of the most important steps. You want to check your solution. Always plug it back into the equation. So if we plug it back into our first equation, 3 times 2 plus 1 does equal 7. 4 times 1 minus 2 does equal 0, so we are on the right track. As we've discussed, there are some things when we plug it back in and it does not equal out. So I want you guys to be thinking, if it didn't hold true, what type of solutions would we have? So your personal opinion now, if you have your notes out, I want you to take a moment, pause the video, stop it. I know you want to keep watching, but stop. And discuss, when is solving systems by substitution easier to do than what we've previously learned as graphing? Hopefully you have just resumed the video, and for the generic idea is that it is easier to use substitution when only one of the equations has a variable that is already isolated. This is like the example that we did in the first video, or some of the examples you have on the worksheet to go with your notes. So let's do a quick quiz to go with your little paragraph that you just wrote, and hopefully I'll have the opportunity to check it in the morning. If you solve the first equation for x, what would be substituted into the bottom equation? So go ahead, pause. This is another check and solve thing. Figure out what would we solve. If we solve for x, what would we substitute into the bottom equation? If you answered negative 2y plus 2, you are correct. If you didn't answer anything, you just waited for the answer, then you are also correct. See how that works out? Remember, guys, you have to know this to be able to apply it yourself, though. It is really easy to go through and find the answers on these videos, but that's not helping you. You will only be hurting yourself. So that's all I have for now. If you guys are needing help, please feel free to see me at any time. Later.